Hi, and welcome back to part 2 of the LANTITE 2023 Numeracy Practice Question Walkthrough. Today we're going to be going through question 10 to 20. So just to remind you that we are still on the calculator active section and you are able to use a calculator that looks like this on the actual day. However, just for today, I'll be using this calculator physical version, but I'll explain everything on screen wherever we see fit. So for question 10, a government primary school employed 40 teachers in 1980. The average number of students per teacher for the school was equal to the relevant average value shown in the table. What was the total number of students enrolled at the school in 1980? So our first step, we are talking about a government primary school. So I'm going to go to government primary. We are also talking about 1980. So I'm going to go to 1980. This here is the value we're talking about. They are talking in terms of 20.2 students per teacher. I'm getting that from students per teacher here in the word. So 20.2 students per teacher. When we say per teacher, we are talking about per one teacher. So that might help a few people to understand this question. We are asked to find the total number of students enrolled in the school in 1980. So we want the number of students in this year. The school itself employed 40 teachers. That is key for us to understand. If they employed 40 teachers, I'm going to write it directly underneath the statement that I wrote down. To be able to get from 1 to 40 teachers, we think in terms of what do we multiply it by, okay? Well, we multiply it by 40. So whatever we do to one side, I'm going to do to the other. Now I'm going to multiply 20.2 by 40, and it's going to give me 808 students. So 808 students for 40 teachers at that school. Question 11, a Catholic secondary school had a total enrollment of 1,098 students in 2021. So Catholic secondary school, I'm now going to go to Catholic secondary. We are talking about 2021, so no longer 1980. Now, the value we are talking about in the middle is going to be 12.2. So we are talking about 12.2 students per one teacher again. Now in this case, I have 1,098 students. So I'm going to write that directly under the students, not the teachers this time. To be able to go from 12.2 to 1,098, I need to think about what I can multiply it by. To save myself the trouble of figuring that out, all I have to do is just do the opposite. 1,098 divided by 12.2 is going to give me 90. So I know that because 12.2 fits into 1,098 90 times, to be able to get from 12.2 to 1,098, I multiply it by 90. I do the same to the other side, and therefore we are left with 90 teachers. So 90 teachers for 1,098 students. So our answer here is 90 teachers. All right, question 12 is on tide times, reading lots of tables here. I'm going to skip down to exactly what it says in the question and then scan back on the table later. The excursion has the following requirements. The earliest time the class can arrive at the beach is 9:30 a.m. and that's the earliest. The class must leave the beach no later than 2 p.m. The class needs to be at the beach at least 2 hours before and at least 2 hours after a low tide. I recognize that we're talking about a low tide, so these ones here will pretty much be the ones that I'm going to look for. But at a quick glance, these are in 24-hour times, and this is near midnight. So it's 10:05 p.m. and 11:30. So I'm definitely not speaking about that second low tide that we have in the day. It's way too late. So in terms of what time the class needs to go here, we're looking at the low tide that I've just kept in highlight. This number 3 condition that we're looking at, so I'm gonna number them. The condition number 3, the class needs to be at the beach at least 2 hours before and 2 hours after a low tide. We're gonna look at that. I need to keep in mind that the earliest is 9:30 and they can leave no later than 2 p.m. I'm going to also scan about what my options are. I have Tuesday, Wednesday, Thursday, Friday. So no one waste your time on Monday. Let's check about Tuesday. Tuesday, the time of the low tide is 10:30, 10:29. 2 hours before that, 9:29, 8:29. That is too early. The class can't arrive until 9:30. So it can't be Tuesday. Let's look at Wednesday. Wednesday, we have 11 a.m. For 11 a.m., 2 hours before that, 10 a.m., 9 a.m. Okay, it's still too early. We're half an hour too early. The class can't arrive until 9:30 a.m. So I'm also just going to discount that. I'm going to look at 11:41 is my next time of the low tide on Thursday. 2 hours before that, 10:41, 9:41. Great, we are after 9:30. Now I'm going to look at the other side of things. 2 hours after low tide, 12:41, 1:41. Great, they're leaving before 2 p.m. So this satisfies the conditions that, like conditions 1, 2, and 3 that we're talking about. So my answer must be Thursday. Okay, question 13. We're talking about weekly rent. Again, it's a table. It is in terms of reading and understanding. What is the median of the weekly rent for the 5 houses? Median, and we're talking about weekly rent. Straight away, I know that weekly rent is here. I'm going to scan the table. That's the column I'm looking for. We also need to understand what the median means. The median is a measure of center in statistics. It is the middle number, but we have to be careful. Yes, it's the middle number, but to be able to find the median, we need to order them from lowest to highest. Lowest to highest. Okay, so we're going to reorder this weekly rent in terms of lowest to highest and then find the middle number. So I'm going to scan and I've got, okay, 380 must be first. Then my next second highest is 420. Then after 420, I've got 440. Then 480. And then 680. Do you notice that I'm actually annotating my work to understand what I've done before moving on? It will really help for your work if you do things like that. Then the median is the middle number. So what I'm going to do is I'm going to cross out from left to right and work my way inwards. Lowest, highest, lowest, highest. Okay, I've got my middle. It is 440. So I look at the answers and my answer is A. Okay, next, event attendance. Again, this is in the topic of statistics, but it is a bar chart for us. Okay, how many more people in the 15 to 24 years category attended at least one cultural event than people in the 75 and over category? So I'm comparing 15 to 24. My 15 to 24 is here. I'm also comparing it to 75 and over. My 75 and over is here. So I'm comparing those two charts there. How many more people? So I've got to compare the amount of people in each of these categories. I need to first have an understanding of what it might go up by to be able to get the exact number for this age group here. So exactly where this line is, I need to figure out that. To be able to do that, I'm going to look at this last one because it's It's where it has those grid lines. It goes from 3,500,000 to 4 million. So I have a difference of 500,000. I have 1, 2, 3, 4, 5 lines to be able to go in those increments. So I know that it's going up by 100,000 each. Each of those lines is going up by 100,000. I might annotate that. Plus 100,000. Yep, so each of those lines is going up by 100,000. So in terms of the 15 to 24 age group, I have got 3,100,000 people. Now I'm going to compare the same for my 75 and over. I can see that I've only got one line left underneath 1,500,000. So it must be 100,000 lower than that number, which is 1,400,000. All right, I need to compare how many more people there were in 15 to 24 to 75 and over. So all I'm going to do is I'm going to do 3,100,000 take away 1,400,000. And I'm just going to do that on my calculator. All right, that would give you 1,700,000. And then if we look at our answers, that is answer B. Question 15. Below are some statements about the graph. Select true or false for each statement. The number of people in the 15 to 24 age group who attended at least one cultural event was more than double the people in the 65 to 74 age group. So we need to look at this age group and we need to test whether or not it's more than double the number of the people in the 65 to 74 age group. So now we're not comparing 75 and over, we're comparing 65 to 74. I'm going to check the number of people in this age group based on the way that I just thought about it before. I can see that it's actually not exact on either of those lines, but I'm going to approximate. So it's just above 2 million. So it's roughly above 2,100,000. It's roughly above that. Keep that in mind. I need to think about what double that number would be. If I doubled the number from the 65 to 74 age group, it's timesing it by 2. If I times that by 2, I would get 4,200,000. If I'm now going to compare 4,200,000 to our age group of 15 to 24, we know that it's actually not double. The number of people in 15 to 24 is lower than the number that we calculated what would be double the age group of 65 to 74. So it is not true. It is false. It wasn't more than double the number of 65 to 74 age group category. Next one. Over 12 million people aged 15 to 54 years attended at least one cultural event. So now we're talking in terms of 15 to 54. So if I'm looking at 15 to 54, I'm looking in terms of from 15 to 54. So I'm looking in terms of these bars. So I need to look at what each of these are and add them all up. And I need to test whether or not it is over 12 million. Okay, so this one here, it's looking like it's at 3,600,000. Then the next one we've got, it's looking like it will be, if I scan across, it's looking like it's going to be at 2, yep, so 2 up, 3,200,000. And then I'm looking at my last bar and it's approximately in between them as well. So it's going to be a little bit larger than our first one. It's a little bit larger than 3,100,000. Only for the ease of understanding this and just approximating, I'm using the closest value. So if I calculated all of those up on my calculator, I'm going to test if it's past 12 million. Okay, I would have actually got 13 million, approximately 13 million if I added them all up onto the calculator. So now that I know there are actually over 12 million people aged 15 to 54 attending at least one cultural event. So that is true. Section 2, calculator is not available. So you are no longer allowed to use your calculator. It must go away. All right, in this, there's 5 practice questions. The actual test has 13 in section 2. Question 16, what is the maximum mass that Tony's full backpack should be? So I'm going to read the question. On a 2-day walk, Tony wants to keep the mass of his full backpack to no more than 15% of his body mass. Tony's body mass is 80 kilograms and he wants no more than 15% of that body mass. So to be able to calculate what he wants no more than, we technically need to find 15% of 80 kilograms. To be able to do that, there are 2 ways. To convert from a percentage to a decimal, we divide by 100, which would mean that we move the decimal place 2 spots to the left. So it would be 0.15, and we can multiply that by 80, and we could set it up using long multiplication. So we could do 0.15 multiplied by 80 and calculate it that way. That is method number 1. But I'd actually suggest to go for method number 2 here. Let's think about it in terms of 10%. Let's break 15% into 10% and 5%. Most people will be able to calculate what 10% of something is. All we have to do to calculate what 10% of 80 kilos, all we do is we divide by 10. So we move the decimal place 1 spot to the left. So technically 80 is the same as 80.0. So we'd move the decimal point here and it would be 8 kilograms. 10% of 80 kilograms is 8 kilograms. So I'm going to just write that it's 8 kilos. And then because we know that 10% is 8 kilos, 5% in relation to 10% is half of that number. So I'm just going to half 8, and then I've got my 5% of what that is. So I've got 8 kilos is 10% of 80 kilograms, and 5% is 4 kilograms of 80 kilograms. I'm going to add the 2 together because remember we're actually calculating 15%. So 8 plus 4 is 12 kilograms. So the maximum mass that Tony's full backpack should be will be 12 kilograms. All right, we're going to move on to cake time. So Samantha plans to make a cake. The recipe times are below. According to the recipe, we want to calculate how long it will take to make the cake. So how long, that's what we're looking for. All we have to do is add up all of the minutes and hours. I'm going to break it up, and I'm going to break it up in terms of hours and minutes. I've already got 2 hours here. I'm also going to just search and say, okay, well, 15 and 45 pair together quite well to make 60 minutes. And because there are 60 minutes in 1 hour, I know that that's also 1 hour. So I've finished with these ones here. I've annotated that. I'm going to bring it off. All I'm left with now is to do 35 plus 50 minutes. I'm actually going to be smart about it here as well. And I know that because there are 60 minutes in 1 hour, I'm going to bring 10 minutes across from 35 to 50 to make a full hour. So to be able to do that, I'm going to take off 10 minutes from 35, which make it 25. And that would make it 60 minutes. 60 minutes is 1 hour. So I'm now going to tally that as 1 hour, and I'm no longer going to have that. So I'm finished here, and I changed this to 25. So I have 2 hours plus 1 hour plus another hour. That is 4 hours in total. And then what I'm left over with is I'm left with that 25 minutes there. So my answer is C, if I scan the answers, 4 hours and 25 minutes. Study load. The equivalent full-time student load is a measure of the student load expressed as a fraction of the year of a subject when taken by a full-time student. For example, the subject within equivalent full-time study load of 0.5 would be half of a normal full-time year of study. What fraction of a year of full-time study is a subject which has a load of 0.125? So pretty much put simply, I just need to find the fraction of 0.125. Now, the work solutions that are published online follow a system where you put it into the nearest whole number and you simplify that fraction. I think I'm going to make it easier, and I'm going to do that from a sense of I'm going to use the information that I've given of the 0.5 and I'm going to work with that. So I'm going to think 0.5. I actually can see a relationship between these numbers somehow. 0.5 is half as a fraction. I'm just going to rewrite this here. So 0.5 as a fraction is half. We were told that. The word half also implies 1/2 as a fraction. Half of 0.5 is going to be 0.25. I know that half of a half would be a quarter. It'd be the same as splitting things into a quarter. Now, this is where I saw the relationship between the numbers. 0.125 is half, again, of 0.25. So then I know that if I'm halving a quarter again, I'm now going to eighths. And I'm going to show you that if you ever got confused of that working out, 0.5, cut it in half. So a half goes there. A half of a half is a quarter. And I can show you that because there are 4 parts now. Whoops. And then a half of a quarter, if I put that many lines in there, I'm going to compare, okay, well, I actually have 8 pieces now, and it's 1/8. So that's how I could compare that. I'm halving it, then halving it again. So I know as my fraction, it's 1/8. Language at home. A recent census revealed that the number of people speaking an Australian Indigenous language at home increased from 63,754 in 2016 to 76,978 in 2021. Which of the following is closest to the percentage increase from 2016 to 2021? What I'm going to do here is, just because I can scan my answers and they are in terms of percentages and it's asking what's the closest to. To first be able to figure this out, I'm going to calculate the change from 2016 to 2021. So to be able to calculate that change, I'm going to do the larger number from 2021, 76,978, and I'm going to take away 63,754 because we're not allowed our calculators. Long subtraction is the way. 8 minus 4 is 4. 7 minus 5 is 2. 9 minus 7 is 2. 6 minus 3 is 3. And 7 minus 6 is 1. So I have 13,224, and that is my change. That is my change of people. So people speaking an Australian Indigenous language at home. It is how much has been increased from 2016 to 2021, which is a nice trend. But now I need to think in terms of percentage. So what I'm going to do is I'm going to think about the percentage increase. So what I'm going to think about is I'm going to first choose A. What is 10% of 63,754? Like we said in a previous question, 10% of something, we move the decimal place, which is originally here, 1 spot to the left. And so 10% is 6,370. I'm trying to read that number. Whoops. 6,375.4. So my change, I'm looking at this is 10%. My change is higher than that, much higher than that. And so if I think about what 20% will be, that will be double the 10%. So doubling this number, timesing by 2, would give us 20% of that. So part B, that will test out our number 2. Doubling that, let's think about doubling 6,000. Doubling 6,000 would be 12,000, but we also have 300. So let's double 300, that's 600. So then, oops, I'm making it challenging. Let's just stick with this. Yeah, there we go, 12,000. So we have approximately more than 12,000. Because I said 600, that 600 is also going to be there. I didn't make it difficult. So 12,600 approximately. It's still going to be higher than that. I know that that there is 20% of my change. 12,600 is quite comparable to 13,224. If I added on another 10% to that, it would be way too high. So my closest percentage is going to be 20%. Sorry, I was stumbling with my words on that one too. Metropolitan movement. The diagram shows the movement of 5,112 young people over 3 years, all of them living in non-metropolitan areas in the first year of study. In the second year, 3% had moved to metropolitan areas and 97% remained in non-metropolitan areas. So when it says 3% has moved, I noticed that the 3% change from non-metropolitan in blue to metropolitan in white is 3% there. My question, of the group living in non-metropolitan areas in the second year, so my second year is here, this is my first, second, and then third. So I'm going to look at that middle bar. In the second year, what percentage moved to metropolitans in the third year? So I'm comparing bar 2 and bar 3. So I want to know how many move from metropolitan, so in the non-metropolitan, so blue, to metropolitan in the third year. So I'm going to look at that bar just like I did before, and it's 5%. So that one was just a reading thing there. And that takes us to the end of the practice question walkthrough for the 2023 LANTITE practice test. It is a shorter version, keep that in mind. You have calculator active and calculator free. If you wish to see some more videos, please just leave a comment just like you did in the previous video. It would mean the world and it would encourage me to create some more to help you through your teaching journey. Thank you.